Hello guys, I'm James for Kit Guru. Welcome back to our Intel NUC 9 Extreme water-cooled gaming system project. I'm just finishing off some Watch Dogs Legion benchmark with the system in its stock configuration to just get some good data to compare against when we've water-cooled the system. The main focus today is to strip the system down again, have a look at the element card in a bit more detail and try and figure out just how we're going to water cool this element card, the RTX 3080. That's going to be pretty simple. We've got a block for that from Alpha Cool, so that uses off-the-shelf parts, but actually water cooling the compute element, that is going to be a difficult task. But before we dive into that, I just want to quickly remind you guys to subscribe to the channel if you've not already done so. Make sure you hit the like button and hit the bell button for notifications. If you want to help support Kit Guru, you can head over to our store, pick up some of the cool Kit Guru merch. So that benchmark's completed. You can see maximum FPS is 105, average is 55 FPS, minimum is 33, and then the 1% lows are 44 FPS. So that gives us a good baseline target to compare the system against when we come to the end of the project, when this is all water cooled. Obviously that's not the only benchmark we've run. I've done a few other gaming benchmarks and a load of stress tests on the CPU and the GPU just to measure the thermal performance in the two different configurations and to measure boost frequency of the CPU and the GPU. So we'll shut this system down, take that compute element card out and go through the options or the ideas that we have for water cooling this system. So those of you that caught the first video of this project, you'll probably remember we had a few minor technical issues. When we open the cover of this, it's going to look a little bit different to how it's supposed to do. Currently we're just using a WD Black M.2 NVMe drive and just some old SK Hynix, I think it's 2133 DDR4 SO DIMMs, just for the purposes of this video so that you can see how tight and how close everything is inside the shroud of this compute element card. So we've removed the top part of the shroud and we need to take the rest of it off so we can get a closer look. It's just held on with there's one screw at the top there, and then if we flip it over, there's another 4 screws on the underside. Interestingly as well, you can see on the back of this PCB, this metal bracket here, this is the stock retention system for the stock heatsink. We'll try and utilize that in our modified water cool solution. So there's all the screws removed. Just disconnect the fan, disconnect BIOS battery. I'll just put the screws back in this. It's quite a handy tip when you're dismantling something like this, wherever you can. So that's the kind of cooling shroud removed completely from the compute element card. That is one thing I am slightly concerned about when we come to water cool this card, is there'll not really be any kind of incidental airflow over the card. So later down the line I might just have to have a look at that and see if we can fit any more case fans into the system. You've also got the M.2 heat sinks there, so they're obviously going to have to be changed for something else. You can see that the M.2 drive is extremely close to this copper heatsink. There's actually a cutout in the copper heatsink there just to avoid contact with that M.2 drive. And also at the other side you can see as well, we're very close to the SO DIMM memory. This stock thermal solution, or this stock heatsink, it is a pretty nice design actually. It's mainly copper, the base plate is copper, it contacts directly with the CPU die. It also has a vapor chamber built into this, and you can see on the end we've got a pretty large aluminium fin stack, and you can also see that the copper base plate, it actually extends and goes down and makes contact with the VRM, so there is probably a bit of passive cooling for the VRM there as well. So we may have to think about that with our design. I'm not sure whether this chip or the VRMs really need any additional cooling. I imagine you could probably run them bare, but if we can provide some cooling to the VRM with our solution, we will obviously try and do that. Also, underneath this top section of the heatsink is the chipset that again has a thermal pad that makes contact with this copper base plate. Whether we'll make our solution do that, I'm not sure. We may try and find an additional aluminium heatsink that can be attached to that chipset. So there's one or two options we're thinking about to water cool this computer element card. The one that we're kind of leaning towards at the moment is to make a copper, almost like an integrated heat spreader that you'd find on a desktop CPU. Reproduce this copper block or this copper base plate without the vapor chamber. Obviously it'll just be a solid copper block. Maybe lop off this top section and do away with the aluminium fin stack. Try as best we can to keep these fixing points, or maybe even retain these spring-loaded screws. If we can, extend this copper block to the VRM just for some kind of active cooling on there. We may have to extend this copper block down a little so that we could potentially then mount on top of there a off-the-shelf CPU block. We've obviously got problems with space on this card, so the height of this copper block will be critical. We've got to clear the M.2 drive on this side and the SO DIMMs on the other side. I'll just remove this block so you can have a closer look at it. It's just held in place with these 4 screws. Try and loosen these off as evenly as possible because this is direct die. We don't want to loosen one side off so that there's real uneven pressure on this and potentially crack the die. We also need to just remove this M.2 drive for now because that gets in the way. I'll take that out. All these screws should be loose. As you can see there, we've got some thermal pads for the VRMs and even on the chokes, and also the thermal pad that goes onto the small chipset that's on there. You can see the 4 mounting holes for the copper block. And if we take a closer look at this stock heatsink, you can see it's a completely copper base plate. You can see there's a large vapor chamber in there, thermal pads of different thicknesses for the chipset and the VRM. You can see there's a well there for the vapor, and then you've got 4 spring-loaded screws attached to this. They're kind of held in place with some kind of circlips. If we are successful with this idea, what we'll end up with essentially is a copper heat spreader that is fastened directly to the CPU die using the stock mounting points. And then in terms of the actual cooling hardware, we've got a couple of different options in terms of CPU blocks. Thanks to AlphaCool, we've got the IceBlock XPX, which is probably the one I'd most like to install on top of this block. And if you can just imagine that this is our finished copper heatsink or our finished copper heat spreader, what we're planning really is just simply attaching the block directly to that, designing our own fixing mechanism. You can see, if you look closely, it is very close to the M.2 drive, and it is also very close to the SO DIMMs. But if we stick to the level that the original heatsink is, we should be able to just clear on both sides the other components. Actually mounting it to the copper plate, we expect to extend the copper plate down as far as we can here. Obviously we've got to be careful of the PCIe slot, so we'll extend that copper as far down as we can, extend it at the top here, use either a modified bracket, as you can see. Maybe if we cut this bracket down, maybe cut it somewhere along here, and then make our own fixing points, we can then fix that down directly to the copper heat spreader. So that's one option. The only problem with this IceBlock XPX is the height of it. When you put that on there, Now it's kind of a similar height to the stock shroud, but then we've got to fit a couple of fittings on there. More than likely they'll have to be angle fittings, so we might be struggling for space between that block and the back of the GPU, so that might be a bit of a problem. If it is, we have another AlphaCool block we could try. This is the Nexus XP3 Lite block. If I put these side by side, you can see that the ICE block XPX, which is this one, is considerably taller than this XP3 Lite, so that will give us additional clearance to the GPU, especially when we've got some fittings in there. This is a slightly different shape, so it might mean that we have to make a different mounting system, or we have to at least make a custom bracket. But there is one good thing about this one: when it is installed that way around, we can get to these screws still as well, just. And then if neither of those fit, as a kind of last resort or a last ditch effort to make this copper heat spreader system work, I've got this all Ragintech. I think this was a GPU block that I used on a 1080 Ti. It was actually really successful on that card, but as you can see, that fits on there, absolutely no problems at all. Quite easily get to the stock screws, and you can see the fittings come out vertically upwards, so there should be no issues with clearance to our graphics card. If that copper heat spreader idea proves to be unsuccessful, there is another option. We could try our own direct die cooling, but that again is going to be quite difficult due to the lack of space on the board. I've searched far and wide for a CPU block that could be modified for direct die cooling, and the only ones I've found are these from a company called Coolants. I've never used them before, but they have some quite small cold plates, they call them, that they're just kind of a CPU block or a cold plate block. There's one that's 25mm by 25mm, so I mean that'd easily fit on this board. That's just a little bit bigger than the actual die itself. And there's also a part number called a GPU 210 cold plate, and that's 35 by 35, and you can see that should quite easily squeeze in. But it's a good backup. We'll try and get hold of some of those just in case our copper heatsink or copper heat spreader idea isn't successful. Another problem with this idea is it's obviously going to need drawing up on CAD and machining with CNC machines, maybe a milling machine, something like that. And the problem is I've only just started off learning CAD. I've only done some real basic drawings. So I'm going to need somebody to draw that up for me. Luckily, at Kit Guru we have all bases covered, and I know just the man for the job. So Luke, how's it going?
All good, all
nice.
Good.
Yep.
Staying nice and virtual and nice and safe.
Good, nice to hear, that's good. I've got a bit of a project going at the moment with the Intel NUC 9 Extreme. You've had some experience of the NUC 9, haven't you?
Absolutely, yeah. So I worked on that in 2020. Really cool system, to be honest. A pretty smart feat of engineering, in my opinion.
What about water cooling it?
Good luck.
Yep, thanks. I'm glad you said that. What about a bit of help with water cooling it? What do you think?
Yeah, it sounds like it could be an interesting challenge.
I think that's more your department, CAD.
Yeah, so I've done quite a lot of CAD work through university and through my previous employment. So yeah, we'll have a look at what we can CAD up and hopefully come up with some form of solution for cooling this CPU, I guess.
I've kind of had some ideas myself, thinking maybe we can utilize what's already on the board.
So ideally, I guess what we would do is just direct die onto the laptop CPU that's in there. But because of the proximity of the SSD and the SODIMM memory, we can't go direct die with the water block.
That's right. No, there's not enough space for that. Definitely not. No, we're gonna have to raise the CPU block to clear those other bits on the board. So that's why I'm thinking, kind of make an integrated heat spreader similar to what you'd have on a desktop processor.
Yeah, precisely. So it serves two purposes then. I guess spreading the heat, which is not fundamentally critical because obviously we could do direct die, but because we can't do direct die because of the proximity of the other components, it's almost acting like a shim to just raise up the profile so that we can put that block on without interference. Yeah. And I think you fitted that on and it fits nicely between those screws, does it?
Well, yeah, if you put the AlphaCool block on top of what we've already got there, it does kind of fits almost central to the mounting screws of the original thermal solution. I do have another alpha cool block as well. It's a bit smaller. Whether that one will work better.
Yeah, so I guess fundamentally the reason we couldn't just slap the alpha cool block on there right now is because the top of the vapor chamber unit is a 2-tier design. So you have got that step of you over the VRMs, and then it steps down to the CPU side. So it's a bit too big to fill with even like thermal paste or anything like that. I guess what we really want to do, because we've just shown that the block does fit, is basically just copy the profile there, make sure it contacts the actual die of the laptop style CPU underneath, then raise the profile to be flush on the top so that we can mount the liquid block on there. And obviously pay attention to VRM and inductor cooling if we need it. Importantly, staying out of the zone of the SODIMM memory and the SSD.
Yeah, I'm just taking off this heatsink. I just need to take one of these SSD drives out as well. So can you see that under there?
I can, yeah. So I think what we can see is is that a 3-tier design? So where you've got the CPU, then kind of the well of the vapor chamber, and then the top surface.
Yeah.
Okay. Yeah. So it's a 3-step design, but fundamentally, because obviously we're going to be looking at doing basically a copper block style heat spreader to dump the heat off to the actual liquid cooling block. We don't really need the 3-tier design because we won't have the well of liquid.
That's
We're
right.
just using solid copper.
All we really need to do then is just extend the this area at the bottom, get rid of this fin stack. That's not needed because water cooling will not need that. Try and keep this area that goes towards the VRM, but it'll all be one level, so that'll be the top face, that it'll be all in one level. CPU block on top of that, and we just need to extend either side so we can actually mount this block to the copper heat spreader.
Yeah, absolutely. So I think basically the way I'm looking at it now is we would take that side piece, like you said, with the VRM.
Yeah.
On CAD, we would just extend it so that it's all flush across the top.
Yeah.
And then just like it is now, where the 4 mounting screws are on a different level, we would keep that the same. So the machinist would just come down with an end cutter or whatever. Yeah. Keep those at a different level, just so that we're keeping the same mounting hardware, the same, just basically all the same mounting specifications as what is there now. So we can reuse the back plate on the NUC board. Yeah. And then we can, like you say, extend a bit further down on the copper. On the copper heat spreader, just to give us some mounting points, because we don't really want to zip tie a water block on there. It'd probably be fine, but I guess we don't want to do that.
No, because it wants to be a bit more permanent than zip ties. Yeah. Definitely. So you can see there you've got the back plate, so that's a good retention system for our modified solution, and we'll also have to think about maybe redesigning these top brackets as well.
Absolutely, yes. What you've got there is that's a AMD, so AM4, AM3 plus style bracket, isn't it? Yeah. And I guess the reason we couldn't use that with the new heat spreader is because they would extend down. So if you flip that NUC 9 card over, we'll see that would extend down to the point where it would be interfering with the PCIe slot. So we can't really use that, can we? However, as you can see, that sits really nicely there. If it was the same level on the top of the heat spreader. And if we were to cut down that bracket, for example, you could have a slot which you could use for an AM4 style mount fundamentally. And so, one on the bottom side, one on the top side.
So basically we'll be using a similar mounting system to this, but just kind of cut down, new holes drilled or new slots drilled, maybe different screws or different fasteners.
Yeah, so it's just copying that bracket, just cutting out the bit that would interfere with the PCIe slot. I mean, fundamentally on the top side, we wouldn't necessarily have to worry because we'd be removing the big fin stack, which would mean we'd have space to play with on the top side.
So I guess the only other thing really then to think about is the VRM cooling. Hopefully that copper plate that we make, that'll extend out like the original one, so that should help with keeping the VRM temperature under control. And then the other thing is that small chipset as well.
Yeah, so I think on the topic of the VRM cooling, I think it will be pertinent, a good idea for us to basically copy the style now and the style with the slot, because I think you identified, didn't you, that the slight slot in that kind of overhang bracket for the VRM is there so that you can still access an SSD and you can get an SSD installed.
You mean this slot here?
Yeah, this cutout. So we'll try and basically copy that as is. Of course, we're going to be manufacturing it ourselves.
I'm hoping to, just adjust that long duration power limit to 100 watts rather than the stock 65 watts. That's kind of what the aim of the project is, to get as much performance out of the CPU as we can.
Yeah, absolutely. So I think extracting the heat from the CPU is going to be the main thing, because the inductors are probably going to be fine with 100 watts. I think is it 5+1 on the inductors, I think.
I think so, yeah.
And then the MOSFETs, if I remember correctly,
yes.
They are DR MOS solutions. I think they were on semi units when they 45 amps each.
Yeah.
So was that 270 amps combined.
Yeah.
My maths is correct, otherwise I'm going to look like a clown. So 270 amps combined on some good on semiconductor units. I'm really not concerned about that. You probably could run them passively, but because you are liquid cooling, there's going to be very little incidental airflow.
There's not a lot of space to play with, and there's not a lot of fan mounting locations, and the only 2 stock fan mounting locations are at the top. They'll be exhausting air out, and they're quite a way away from the VRM. But if there's any scope to add extra fans into this system, hopefully it'll give us some performance improvements, and we'll have one of the most powerful small form factor water-cooled gaming systems you can get.
Yeah, it would be cool actually, because the vapor chamber unit itself is a pretty good unit. Obviously it's got a small fan, so that kind of limits the usefulness of it, but it's a really cool design. So it's not going to be easy to outperform it, I don't think, but I would hope with some good alpha cool hardware there for the liquid cooling and a relatively competent copper heat spreader, fingers crossed we can do a reasonable enough job.
I'll get that over to you. You can work your magic with that, and I'll try and work my magic with everything else.
Sounds good. It sounds like I got the easy task here in that case.
I think I have, yeah. So while Luke's getting on with the drawing, I've got a bit of time to kill, so I think I might try and see if I can sort of mock up what we're going to do using the original heatsink and trying to attach one of these, probably with some tie wraps or something, just to see if it makes any initial difference to thermal performance. I'm hoping it does. To kind of start with that, I need to just remove this like extension plate that goes to the VRMs. Looks like that is soldered in position, so hopefully the heat gun will help get that off. So I'm just going to stick it on this block of wood so I don't completely ruin this desk. Some small plastic washers on those screws, but we have another one of these, so if I kill this one, we can always use that one as a backup. There's also some kind of tape or something insulating that from maybe some other components on the board. But let's just try and get this off and see what happens. So that's extremely hot, but it seems to have come off quite nicely. I'm just going to have to tidy up that bit of solder that's there. So that's cooled down a bit, but it is still a little bit hot, so I'll just put on some gloves. Just going to see if I can scrape off some of that solder using a Stanley knife blade. So that is as much of the old solder scraped off as possible. That's the old bit that went to the VRM heatsink. And then I'm just going to try and smooth this surface down as much as possible using a bit of 600 grit wet and dry. So I just got a small block of wood. You can see it's getting there. There's still a slight hollow in the middle, so let's keep going with this wet and dry for a bit longer. It should be good enough for this experiment. And get rid of this heat gun now, we don't need that. Just wipe up on the desk. We'll also have to make do without this VRM heatsink for now, so we'll remove these thermal pads. We can leave the thermal pad on the chipset because we still have that part of the cooler intact. I'm just going to clean off this old thermal compound. Get a bit more thermal compound. Just pick any will do. Should be enough. And then screw this back down in position. These are actually numbered, these screws, so there is a tightening sequence, so that's number 1, 2, 3 and 4, so we'll tighten it down again in that sequence. So that's the original heatsink refitted. Just see what clearance we've got inside this case. So that's both cards installed, and you can see that's the space we've got to play with. If I just take a rough measurement from the top of that copper cold plate, it's between 49 and 50 millimeters we got to play with. So eyes block XPX, that's about 30 millimeters tall. That sounds like it's going to be a bit tight getting one of those angle fittings on that. So that fitting, that's 28 millimeters tall probably, so that might be a struggle. Let's have a look at this other block. So that's about 17 to 18 millimeters tall, plus the fitting. We can actually screw this on, measure the total height, which is about 47 millimeters. So that one might fit, but it's going to be extremely tight. So let's take this card back out. So because the stock mounting screws sit quite proud of the actual copper block, when I drop this block down, this water block down on top of that, it doesn't quite make contact with the copper plate. So I've just marked out where those screws are positioned. I'm just going to take some notches out of this plastic edge. It is there for a purpose, this. It's to locate the upper mounting bracket, but I think just taking 4 notches out of that shouldn't make much difference, and then it should allow us to just drop that block down onto the copper heatsink. So I think I'll just have to run them down on maybe the bench grinder or something like that. I think the bench grinder will be good because it'll take a decent sized notch out of there. So I'll just run that down on there and see if it fits afterwards. So that seems to have worked. Just put 4 notches in that kind of rim. This bracket still has plenty of meat to grab onto, so that should be fine. And that now makes full contact with the copper plate. So next step is try and mount that somehow. I'll just screw in a couple of these 90-degree angle fittings first. That's one. In fact, I just found some different 90-degree angles. These ones allow the tubing to go directly in there, so less connections. So I'll get rid of that one. We'll use these instead. I think these are the same, roughly the same height. Yeah, they're more or less identical, so less connections and less possible chances of a leak. So I'll use these ones instead. So that is potentially our CPU block. Seems to fit all right on there. Just reinstall this M.2 drive and make sure we've got enough clearance to that. Making these cutouts like notches, it does allow us to have a bit of play there, but we've got plenty of room. It actually sits pretty centrally and still manages to miss that M.2 drive, so that's good news. The next thing is cover that base plate. Well, first remove that sticker, and then I'm going to stick a load of thermal compound on here. that's pretty evenly spread. So I think the zip ties are in order for this next bit. That's got decent mounting pressure. In fact, I'll just give it a bit of a wiggle. See if that improves it at all. Maybe that were a bit too much. Let's try again. I think that's good enough mounting pressure. It's not wobbling about too much, so just snip those bits of those tie wraps, zip ties off. Might as well leave those top bits on, they're not going to interfere with anything. So that is kind of what we're trying to achieve. Obviously on the finished product we shouldn't need this aluminium heatsink, that shouldn't be necessary, but that is more or less what we're trying to achieve in terms of the compute element. So we need to obviously now sort out where the pump's going to go, sort out where a radiator is going to go, because that also is going to be quite tricky. That's not going to be able to fit inside the case. I can see just by looking at that that's not going to happen, so potentially we'll be having an externally mounted radiator. We have options of either a 2x92mm or a 240mm rad. Both of these are 45mm thick, so hopefully that'll be enough surface area to cool this CPU as well as the RTX 3080. Obviously we also need to get this water cooled, but again, thanks to Alpha Cool, we've got an off-the-shelf Founders Edition GPU block for that. That's going to be great because this will cut more or less a third of the card off and allow us a bit more space inside that case for mounting our pump res combo. Before we go any further, I'm just going to check that the system still posts in this kind of configuration that it's in at the moment, with that CPU block just tie wrapped in place. I'm a bit worried that when I snap that tie wrap, it could have potentially hurt something. I've got this fan just temporarily wired up just for a bit of airflow onto that heatsink. Everything else is connected up normally. Just using the built-in iGPU for now. No need for the graphics card. Connected up to power. So turn it on. Just hit the power button. The system actually booted straight into Windows. It's all looking alright for now, so I think I'm happy that I've not damaged anything. Happy that the system will boot up without a CPU fan install, which is good. And we can move on. Package temperature currently is at 43 degrees C, which is pretty normal for the idle temperature of this system. Actually, now I've plugged that fan in, it's dropped a couple of degrees already, down to 38 degrees C. Maybe a quick stability test with AIDA64, stressing CPU, FPU and cache. Temperature's still 38, 37, actually dropped to 35 degrees there. So that's running 100% CPU load now. Package temperature 77 degrees, 79 degrees, 81, 82. It's still much lower than it was before. It's not hit actually it hit 96 degrees without the fan running, and we're still around 87, 91. It's dropped back to 88, 75. So I guess the 65 watt power limit has kicked in now. It's actually dropped right back now, 77 degrees, 74. So that is a lot closer to how the system performs in the stock configuration with the stock fan blowing on that heatsink. So I'm a bit more confident now that that water block's fitted correctly, and I think we can actually now move on. Maybe get the water block fitted to the GPU, and then in the next part or the next episode of this water cooling project, we'll be installing the water block to that 3080 Founders Edition. I've not seen much footage of a custom water block being fitted to those cards yet, so I'm really looking forward to that. I know that taking this apart might not be too easy. All the screws and fittings and everything are all hidden, so that'll be interesting to see how that comes apart and how the water block is fitted. So make sure you keep an eye on the Kit Guru website for the next installment of this NUC 9 Extreme water cooling video. We'll be fitting that GPU block in the next installment, also figuring out where we're going to fit the pump res combo, how we're going to mount radiators, and basically getting the rest of the loop together and doing some real thermal performance tests in this kind of mock-up situation. Don't forget to hit the bell button as well for notifications, and hit the subscribe button and like button if you've enjoyed watching this video. And as always, you can head over to kitguru.net, catch up on all the latest in-depth hardware reviews, catch up on some tech news and gaming news as well, and you can connect with us through our social media channels such as Facebook, Instagram, Twitter, and you can also connect to our Discord channel. Thanks for watching. I'll see you next time.